Hello, good morning, everyone. Let's get started. We will continue to talk about lecture one today, the scientific method. We probably will be able to finish today. So just a quick recap. Last time we talked about how there are two approaches in science, right? There is the um, discovery science aspect of it, which is where we are going to be making observations, and these observations can be qualitative, which are things that we observe by using our senses, or they could be quantitative, which involves some kind of measurements. Okay, and then from these observations that we are able to come up with some generalization. Okay, so from the specific cases to the general statement, we call that inductive reasoning. And many times we are able to use that generalization and apply it to other cases that are similar, right? And taking that general statement and applying to specific cases, that will be example of deductive reasoning. Okay, so that's discovery science. The other aspect is hypothesis-driven science. Okay, so this is going to be the focus of today's lesson. Okay. So in this hypothesis-driven science, or the scientific method, really, there are different steps along the way which are going to guide the process, and it involves setting up an experiment and testing some of the um, hypothesis that you set out for a particular scenario, and that's what we're going to learn to do today. Okay, so I hope you have your study guide, because we'll be using that for today's lesson. Okay, so let's start with a very simple scenario here, something that you probably had experience with. Let's say you watch TV and you pick up your remote and you aim it at a TV, you press the button, nothing works, right? So the observation that you made is the remote doesn't work. Okay? So after observation, we have questions about the observation. So in this case would be, what is wrong? Right? What's wrong with the remote? Right? That's probably your first instinct, right? And you want to try to answer your own question, right? You have some guesses as to what is wrong with the remote, maybe from past experience, okay? Maybe just from intuition. And so in this case, a possible reason is that the batteries are dead. Okay, so once you make your hypothesis, we'll talk more about what exactly hypothesis is, but basically it's a tentative answer to your question, right? Then you want to make a prediction, right? If my hypothesis is correct, then that means if I change the battery, it will fix the problem. Okay, so you go ahead and you replace the battery. That's your experiment, and one of two things can happen. Okay, the remote works down. Okay, once you replace the battery, then you can go watch TV. Then the experiment supports the hypothesis. It means you were correct, and the problem is solved. But it's also possible that you place the battery and it doesn't work. It still doesn't work, right? The remote. So then you have to revise your hypothesis. You have to come up with a new hypothesis. Okay, maybe it's not the batteries. Okay? Maybe it's the problem with the TV actually. Okay, maybe you forgot to plug it in or something like that. Okay? So like you have to keep on revising the hypothesis and keep on testing it until you are able to solve the problem. Okay. So that is basically the core of hypothesis-driven science. So let's just break it down a little bit more. It begins with, again, the observations that you're making, and then asking questions about those observations. Right? And to find the actual answer, like you have a tentative answer, you have a guess as to why things are the way they are, but you must test them to see if you're right, right? So the process in which you test that hypothesis, that's what's called the hypothesis-driven science. So, you might observe that some plants grow taller than other plants. Okay, that's an observation. And the question would be, why do some plants grow taller than the others? Okay, especially if you grow them in the same house, right? Why is this one growing taller than the other? There could be various hypothesis to this. There could be various guess as to why this is the case. Maybe one receive more sunlight than the other. Maybe one, you water it more often than the other. Right? So there are various, people call it educated guess, right, as to why this is the way it is. But to follow through, you have to do an experiment to test to see whether or not your hypothesis is actually correct. So what is exactly a hypothesis, right? A hypothesis, it's like a tentative answer, I said. Tentative answer. Right. People say educated guess. I don't really like that. It's not really a guess, okay? Like you have to have some kind of logic as to why you pick the answer to be. Right? And you will be asked to write hypothesis, maybe on the quiz, and definitely in the lab that's coming up later on in the course. Yeah. So in order for a hypothesis to be valid, it must satisfy two conditions. It must be testable, and it must be falsifiable. Testable is pretty straightforward. It means you must be able to conduct an experiment to verify whether the hypothesis is correct. Okay, so the experiment either will support the hypothesis or it will reject the hypothesis. Okay, don't use the word proof. Okay, in science, you cannot prove anything. Okay, you can only gather data to support a hypothesis. Okay, we will continue to use a hypothesis until maybe later on some new evidence rejects it. Okay, so you can't really prove something. You can just say this is the best model based on the data that we have. Okay, and then maybe one day, right, someone will come up with new theory that would reject the hypothesis, reject the current model, and then you would have to modify it. Right, that's very common in science. So it must be testable. And the second criteria is that it must be falsifiable. Falsifiable means potentially wrong. Okay, and I'll give you more example of what that means in a second. Things like opinions, cultural, religious beliefs, superstition, myth, value, moral judgment, supernatural stuff. All these things are not testable. Okay, you cannot test someone's opinion. Right, there's no right or wrong. Right, you cannot support it or reject it one way or the other. It's the person's personal opinion, right? And that goes for all of these other things as well. Having said that, let's take a look at some invalid hypotheses. Animal testing is bad. Right? That is not a valid hypothesis because that's an opinion. Right? To you, maybe that's true. Maybe you are against animal testing, and that's fine. But other people might think it's a good idea, right? To be able to have an animal model that mimics a particular disease, and then you research on that. Right? So again, right? No right or wrong here. Personal opinion cannot be a hypothesis. Rock music are better than classical music. That is also an opinion. You cannot prove that one way or the other. So that's a bad hypothesis. Next one, the garden fairies made some plants taller than others. Right? So this is like supernatural stuff, right? Superstitious stuff, right? So that also is not a hypothesis. Right? So anything that's like, not grounded in reality, so to speak, right? That's not going to be a valid hypothesis. And also this is not only is this superstitious. Let's just take aside the superstitious aspect of it. It is also not falsifiable. How do you prove that the garden fairy doesn't exist? Right? Like, how do you show that, right? The garden fairy doesn't exist. You just can't. You can sit in the garden for your whole life and not see a single garden fairy, but that doesn't mean they don't exist, right? Yeah, like it's not falsifiable, in other words, right? That's why it is also an invalid hypothesis. Do you understand that? Just because you haven't seen one doesn't mean they don't exist, right? Okay. Next one. Everything that occurs is as a result of divine intervention. Again, this is superstition. And number two, it is falsifiable, non-falsifiable. Okay. There's no way to prove it wrong, to show it wrong. Okay. There's no way to reject it. Okay. So that's why these things are invalid hypotheses. Let's take a look at some good ones. Okay. Plants receiving more sunlight grows taller. Right? That's possible, right? To test, we can put some plants in sunlight, some plants in the shade, and see if we are right. Okay. You could potentially be wrong. Some plants actually don't like sunlight, and the result might be the other way around. Right? So it's both testable and falsifiable. Another one, driving with windows down will increase fuel consumption. See, this one is like a greatest debate. It's people have, right? Some say if you drive with the window down, you're not using your AC, you're not using your heat, so you save gas. But other people are saying, well, if you get all your windows down, right, all the winds are coming in and it actually creates air resistance and it decreases your car efficiency, right? So that's very easy to test even on your own. Right? If you're driving, right, you can see how much gas you use with the windows down versus not down, right? And you know, potentially you could be wrong. That's why it's a good hypothesis. Right? Taking melatonin will increase sleep duration. Does anybody know what melatonin is?
Yes, sir.
Yeah, what is it?
It's a sleeping tablet.
You take to make you sleep better.
Yeah, you take it to make you sleep better, right? But do you guys know your body makes your own melatonin?
Yeah, actually, it's we have it on our own body, and we can take some pills to sleep better because it's replaced in our body like the one that we have.
Right. So that's very good.
It's like a hormone, yeah.
It is a hormone, exactly. So in our brain, there is a part that makes melatonin, and you usually make melatonin when it's dark, okay? And that signals you to sleep. That's why, like when I teach at school, I never turn off the lights in the classroom when I do use the projector because that just puts everybody to sleep. But at night, right, when it's darker, your body starts to make more melatonin, and then you feel sleepy, and then you go to sleep. That's why they say, right, like don't look at your phone too much, or watch TV right before you sleep, because all those bright lights gonna, you know, mess with your melatonin production, right? So some people take melatonin thinking that it's gonna help them sleep better, but you know, some studies suggest that it's all placebo. Okay, if you don't know what placebo is, that's okay. We're gonna learn about it later today. But it just means that it's all psychological. It's all in your mind. Okay, like you could have given them something else and tell them it will help them sleep, and then they will sleep better, right? So you know that's something that's worth testing, right? Taking melatonin will increase sleep duration. Does it? Right? So you can run an experiment to check that, you know, and it could turn out that it doesn't. That means it's wrong. So it's falsifiable. Okay. So when you write a hypothesis, you have to make sure that you know, it satisfies those two conditions and it makes sense. Does anybody have any question? We'll practice doing hypothesis in a bit, but before that, any question? Great. All right. So designing an experiment, right? This is one of the most confusing thing for many students. Okay, when you design an experiment, we use the experiment to check the hypothesis to see if it's correct or if it needs to be tweaked, right? And when you conduct an experiment, there are many things that we can change, and something that can be changed is called a variable. A variable. Okay. When we set up an experiment, everything else should be kept the same. Everything should be standardized. Everything that can change should be kept standardized, except for two things. Okay. And those are the dependent variable as well as the independent variable. So what is it? The independent variable is, I'm just going to read it to you first and I'm going to explain. Okay. Condition deliberately changed by experimenter to observe how it affects another dependent variable. What does that even mean? Okay. So independent variable is the one that you are in control of. In control of. Okay. So this is the one where you are purposefully making changes to. For example, we were saying earlier, you know, some plants grow taller than the others because they have different amount of sunlight, right? So in that scenario, the independent variable would be the amount of sunlight. I deliberately put a plant in the sun and I deliberately put the other one in the shade, right? So the exposure to sunlight, that's something that I am in control of. That's the independent variable. Now, what are you trying to achieve here? In the experiment, by changing the independent variable, by manipulating the independent variable, you want to see if it has an effect on the dependent variable. Okay, so the dependent variable is the one that you will be observing, is the one that you will be studying, the one that you will be measuring to see if it was affected by the independent variable. So in our case, right, we put some plants in the shade, we put some plants in the sunlight. What would be the dependent variable in that case? What are you trying to observe? What are you trying to measure? Anybody?
To see if the plant is going to grow taller in the sun.
Exactly, right? So, you know, the independent variable is the exposure to sunlight. And then you want to see whether or not exposing it to sunlight, more sunlight or less sunlight, will affect the height of the plant, right? Plant height. Okay, that's not something you can control, right? Like, I cannot like make the plant grow taller or you know, make it grow shorter, right? Not directly, right? But what I can control is whether to put it in the sun or not. Okay, so there are always two variables that you have to keep in mind when you do an experiment. One that you can change and one that you are just observing and measuring. Okay, so back to here, we have the hypothesis. Some plants are taller because they receive more light. The experiment, we will have one plant where we will give them like 6 hours of light exposure per day. And then here we'll give them 12 hours of light exposure. Okay, so one gets more than the other. Okay, maybe we don't keep it like totally in the dark. That's where we're going to kill the plant. But you know, more light for one and less light for the one. Okay, so with the prediction, right? What's the prediction? If I'm correct with my hypothesis, then this one should grow taller over time compared to the one that only gets 6 hours, right? That's the prediction. If the hypothesis is incorrect, then they either grow the same amount, or maybe the one that receives less sunlight will grow taller. Okay, so you always have to think about what are the possible results if I'm correct and if I'm wrong. Do you understand? And let me say that one more time. If the hypothesis is correct, you would expect the plant that's receiving more sunlight to be taller, right? Like this one, the one receives 12 hours. If we're wrong, either they grow by the same amount, or they the one that receives less sunlight grows taller. Those results would tell me to reject my hypothesis. Okay. Now, when you set up the experiment, it is very important to keep everything else the same, except for the independent variable. In other words, other than the amount of time that you expose the plant to the sunlight, everything else needs to be the same. For example, we have to use the same type of plants. Okay, you want those plants to have the same starting height potentially. Okay, the soil type should be the same, amount of water, type of light exposed. Are they both sunlight, or are you using like one of those indoor, greenhouse light, right? Humidity, temperature, all of these things should be standardized. Okay, all these things could have changed, but we are standardizing it. We're making it the same for our experiment. That is very important, because in the end, when you see one plant gets taller than the other, you can say with confidence the difference in height was caused by the sunlight only, right? It's caused by the amount of sunlight, not by any of these, because they were all kept the same for both groups. Okay. See, if you change the sunlight, and then let's say you didn't standardize the soil type, okay? You use different soil, okay, for the plants, and then one becomes taller than the other, then you don't know, was it the sun that caused them to grow taller, or was it the soil type, right? So to make sure that whatever difference you see is caused by the difference in independent variable, you have to standardize everything. Okay, so let me write this down to you. Okay, the purpose of standardizing we can say standardized variable. Okay, the purpose of standardized variable. Right. This ensures any difference observed in the dependent variable is as a result of changes in the independent variable. Okay. In our scenario, we want to make sure that the difference in height was caused solely by the difference in temperature and nothing else. Okay. If you want to ask some questions to, clarify things, please do.
Can you please explain again the dependent variable?
The dependent variable?
Yes.
Yeah, sure. So the dependent variable is the one that you are just observing, that you are just measuring. Okay, let's go back to here. Driving with the windows down will increase fuel consumption. Let's do a poll. All right, let me see where you guys are at. Okay. Sorry, I'm just trying to grab my pen here. So A is window position. Okay. Open or close. And B is fuel consumption. Which one, if I'm doing an experiment to test this, which one would be the independent variable? Okay. Is it the window position or is it the fuel consumption? Which one would be the independent variable?
Fuel consumption?
Oh, sorry, please do the poll. I just launched the poll, but thank you, Mona.
I'll close it. I'm sorry.
Oh, no worries. That's okay. Yeah, just
Again with the question, please.
the question is, if I'm going to do an experiment to test this hypothesis, which one would be the independent variable? Which one are you going to be in control of? That's the way you remember it, right? Independent is the one that you can change. Hey, you guys are pretty good with the polls. You know, thank you for participating. Sometimes it's hard to get people to participate in an online environment. Yeah, I mean, most of you got it, right? Like the window position, whether it's open or not, that's the independent variable. That's the one you can control, right? Like you literally open the window or you close the window, right? That's your choice, right? You can control it. And what are we trying to measure? What are we trying to observe, right? You are trying to see whether or not the fuel consumption increases or decreases. That's something that you need to measure, right? Okay, like maybe you look at the fuel gauge, right? To see, you know, oh, I use more fuel this time, right? So that the fuel consumption would be the dependent variable. Okay, we'll just do another one. Taking melatonin will increase sleep duration. Okay, so what can you control? You can control whether to take the melatonin or not take the melatonin, right? So that's going to be the independent variable, taking or not taking melatonin. That's independent. And then dependent would be the sleep duration. How long did you sleep for? Okay, that's something that you have to observe, right? You know, oh, I slept for 5 hours or I slept for 6 hours, right? Something like that. Hopefully more than that. Does that help clarify things a little bit?
Yes.
Okay.
Uh,
Yeah, go ahead.
Can you say this like the variable one is our result, like our end, what we see at the end of our experiment is the variable, right?
Which one, the dependent or the independent?
Or like the dependent.
That's
Like
right. The dependent is the
end of the-
outcome, right? Yeah, that's
Yeah,
right.
the
That's one way of
outcome.
looking. Yes. Okay.
Okay.
Very good. Okay. You know, we're gonna do an exercise right now. If you have the study guide, please go to, I think, page 2. Okay, we're gonna be doing number 6 right now. Okay, number 6. Now I am going to put you guys in groups, and I want you to work on these questions. If you don't have it, you can just look at it from the screen, I guess. Actually, I don't know. Sometimes I think when I put you in groups, you will lose the screen. Do you guys have the study guide? Okay, let's do a quick poll. Just to tell me, if you have the study guide, please choose A. If you don't have it, please choose B. Do you have it or not?
So where do I find it in in the table of contents?
Hold on. Let me just post a link on the chat. Okay, so if you don't have it, a lot of you don't have it actually, which is fine. Okay, I just posted the link. Oh, thanks, Steven. You beat me to it. I just posted the link on chat, and Steven did that as well. So if you don't have it, you can click on it, and it will take you right to the study guide. And we are looking at question number 6 right now. Okay, question number 6. Okay. So what I'm gonna do is I am going to put you in groups. How many people do we have here? We have 30 people. I'll break you into like maybe 6 groups, I guess. And I'll give you like 5 minutes roughly, and you guys could go through the scenario, talk about it, you know, say hi to each other or something, and then figure out what the independent and dependent variable will be. And then we'll come back together and take it up. Okay, do you guys understand what you have to do? I'm gonna put you in groups. You're gonna read the questions, okay? And then you're gonna take up decide what the independent and dependent variable is. Okay, so the person in your group whose first name is the like alphabetical order, the one who starts with the like the earliest alphabet, that's the person who's going to be the group leader, and he or she is going to read the question, and then you guys are going to talk about the independent dependent variable. Okay, so you know, alphabetical order, first person, that's the group leader. All right, go. Hey guys, just dropping by to see if you guys are doing okay. I don't see a lot of discussion going on. Did you guys finish already?
It's mostly through the chat.
Oh, okay, I see. Yeah, that works then. But you guys have any question you want to ask me? No?
I think we're okay.
Okay, great. So I'll see you guys in the
Okay.
class in a bit. Okay, thanks.
Thank you.
Sir, that was a short time.
Oh, was it? Okay, next time I'll give you guys more time. Hey, but very good. I saw you guys like I can see the my icon moving right in each of the groups, and I see that there was a lot of discussion, which is excellent. Okay, that is. I hope you get to meet some of your fellow classmates and complete a few questions along the way as well. Okay, so we'll do more of that. There will be opportunities for that later on in the course as well. Okay, let's take it up right now. First question, students watch a cartoon either alone or with others and then rate how funny they found the cartoon to be. So the independent variable in this case is going to be whether watching the cartoon alone or with others, right? Okay, if you got a different answer and you don't understand, you can just raise your hand and then I will explain it again. Okay, but that's the one you can control. You can either let them watch it by themselves or put them with others, right? With others. So that's the independent variable. And then the dependent variable would be the rating, right? The ratings of how funny the cartoon is. Okay, that's the end result that you want to see. Next one, a comprehension test was given to students after they had studied textbook materials, either in silence or with the TV on. Okay? So the independent variable here is going to be studying with or without TV on. Okay. And the dependent variable, what's a dependent variable? It's not explicitly stated in the scenario. Anybody want to share?
The result, maybe?
The result of what?
The test.
Comprehension.
That's right, exactly. Result of comprehension test, right? Some elementary school teachers were told that a child's parents were college graduates and others were not. They then rate the child's academic potential. So the independent variable is whether the teacher knows about the child's parents' education background. Okay, whether teacher is aware of the child, parents, education.
Can we write here the parents' education, or we have to mention like if whether the teacher is aware or not?
Yeah, so it's not just the parents' education, right? It's it's really about whether or not the teacher knows about it, right? Because what this scenario is trying to teach is whether the teacher will have different perception of the student's potential based on what their parents' educations are, right? Right. So like sometimes the teacher might have bias. Oh, your parents are college graduates. Okay, then you must have very high academic potential, like that kind of bias, right? So that's what we're trying to test here, right? So it's not just the parents' education, it's whether the teacher knows about it. I think that's the key thing here. Is that okay?
Thank you. Yeah, that's good. Thank you.
Okay, so the dependent variable is going to be the rating, right?
Academic potential.
That's right, the rating of the academic potential. Now, I just want to emphasize again, in this case, right? We are not testing whether the parent's education has anything to do with the student's academic potential. What we are testing in this scenario is whether the teacher's perception on the student's academic potential is going to be different if they know or not know about the parent's education. Do you understand the difference? Right. This is just about the teacher's perception, right? Yeah. It's not actually looking at the education versus the kids' academic potential. Okay.
So Vincent?
Yep.
How does like the teachers knowing the kids' parents or either college graduate or high school graduate affects the academic potential? Like I couldn't like join the independent variable. I thought it was the result of the independent variable is the dependent variable, right?
Okay, so like, you know, whether you tell them about the parents' education or not, that's something that the experimenter has control over, right? You either tell the teacher, okay, this kid, you know, parents goes to university, this kid's parents has PhD, whatever, right? So you can control whether to tell them or not. That's what makes it independent variable. The dependent variable is now that the teacher knows or not know, is that going to affect how they see their students' academic potential, right?
Oh.
That's what it means.
Okay.
All right. Shumana, I see your mic is on. Do you have a question?
No.
No? Okay. All right. Last one. Students at a university were split in two groups and each received a different text or for a philosophy course. One group received traditional textbook, the other received interactive tablet. So the independent variable is the type of teaching material, right? Is it just a textbook? Is it an interactive textbook, right? Type of textbook, I guess we can say it's probably okay. I mean, there's more than one way to phrase this, right? And the dependent variable would be scores on exam, right? Scores on exam. All right, so that's hopefully that clears independent and dependent variable. You will have to know this for the quiz, for the test, and for the lab. So make sure you have a good understanding on this thing. Okay. I actually did a little experiment myself since the pandemic, right? I wanted to know if online learning is going to be easier. Like, are students gonna be doing better online compared to in person, or you know, are they gonna do worse? It was surprising results. I'm not gonna tell you what it is. I'm just gonna tell you it's surprising.
I
Yeah,
have a
go ahead.
question.
Sure, please.
Sorry. Is it important to take note of like how it is written in the problem, or can we like for example in letter B,
Mhm.
versus independent variable, you said studying with or without TV on. I actually wrote study environment. Does it make a difference? Or is that all right, or is it not okay?
Yeah, it's okay. Yeah, that's fine.
Okay, so it's thank you.
Yeah, if you can be specific, great. Sometimes, as long as it applies to the context of the question, it's okay. Yeah, not a super big deal there. All right. Good. I hope you learned something there. But I want you to also keep in mind, right? There are all these standardized variables that must be maintained unchanged for all of the groups when you do an experiment. We're going to come back to this in a bit. Okay, so predicting the result, I told you already, right? If the hypothesis is correct, then the one with more lights will be taller. Otherwise, they both either have similar heights, or the one that gets more light actually becomes shorter, right? So in these cases, we would have to reject the hypothesis. And then if this is the case, then we would accept the hypothesis. Okay. So then we collect our data, right? We have the same initial height here, 12 and 12, 6 hours, 12 hours. And then you let the experiment run for 7 days, right? And you can see the one with 6 hours only grew 1 centimeter, and then the other one grows like 6 centimeter. So then you can go ahead and conclude that, oh, more sunlight is going to make it grow taller. Okay. Now this is a very oversimplification of what actually goes on. Okay. When people actually do experiment, they do not make conclusion based on one single test. Okay, that is very, very bad science, right? You actually have to do it with a large group. Imagine testing a new drug, okay, and then the person takes it and like, oh, I feel better. All right, let's mass produce it and sell it on the market, right? What kind of science is that, right? It's really, really a bad conclusion, because it's based on one single result, right? Nobody does that in real life. Okay, in real life, you have to have multiple trials. You have to have a large sample size to make the science more credible, right? To make the results more convincing. But this is just like I said, oversimplification. Okay, let's do some concept check questions, some polls, see if you were with me along the way. Here we go. If you don't see the poll, that's okay. You can just either share your answer in the chat if you want, or just write it down yourself, and you will know when we take it up.
Can you read that question out loud? I'm just not able to move the poll.
Oh, okay. Which of the following steps in the scientific method involves producing a tentative answer?
Thank you.
Okay, just a couple more seconds. Just choose something. Okay, thank you, Yuchi. All right, here we go. Those are the results. All right, tentative answer, right? That should be hypothesis, right? Hypothesis, right? Not observations, right? Observations, you're just seeing things, right? You're like, oh, some plants grow taller than the others. Okay. Oh, some days my fuel consumption is good, other days not so much, right? Those are just observations, right? But to actually come up with a possible answer to your question, that would be hypothesis. All right, here is another one. Let's read the question first, and then we will launch the poll. A set of actions or observations designed to test specific hypotheses are called what? Let me relaunch the poll. Okay, couple more seconds. These are pretty straightforward stuff. Okay, great. Most people got it. That would be the experiment, right? Set of actions, right? Okay, not the data. The data would be the result, right? That you collect from your experiment. Okay. Next one. Oh, that's it. No more next one. So the conclusion after you collect all your data, right? Either your data supports the hypothesis, right? Then you will say, you know, more light will make the plane grow taller. Like I said, in real life, usually the process is more vigorous, and it usually also leads to more questions. Okay, so for example, if you found out that the sunlight makes the plant grows taller, you know, the next question you can ask is, what is the optimal amount of sunlight that will create the tallest plant? Okay, so like in our experiment, we did 6 hours versus 12 hours, right? Maybe try it out. Maybe let's do, you know, 14 hours, 16 hours, right? 24 hours, right? What's the optimal amount? Is there such thing as too much light, right? That's possible. Right? You won't know until you do another experiment, right? So in the context of, like, you know, testing a new drugs, right? You found out that, oh, this drug helps relieve the symptoms of whatever, okay? And then you want to find out the optimal dose, right? How much should you give the patient? In that case, too much is definitely not a good idea, right? You might have unwanted side effects. Yeah. So deciding on what the optimal dose is will require careful planning and experimentation. All right, let's shift gear and talk about, you know what, actually, let's pause for a second. Give me one moment here, guys. All right, I want to do one more scenario with you guys before we let's go to here before we move on to the next topic. All right, Miriam, you have a question? No? Okay. So let's say we have a person, okay? You can call him Josh or something. Okay. So he likes to run, and he bought like 3 pairs of shoes, okay? Like shoe A, okay, and shoe B, different brands of shoes, and then shoe C. He wants to know if wearing different shoes is going to increase his endurance. Okay, like, is he going to be able to run further wearing one shoe over the other? Okay, so endurance, right? How far can he run? Okay. So just think about it to yourself for a second. Yeah. Which one is the dependent variable and which one is the independent variable in this case? Just think about that. And you don't have to tell me. You can just think about it. So hopefully, you decided that the which shoe he wears is going to be the independent, right? Okay, so which shoes he is wearing. Make sense? He gets to choose. And then the dependent variable is going to be the distance, right? The distance. So he's gonna do this experiment. He's gonna wear different shoes, and then he's gonna do the run and see if it affects him. So I want you to give me 3 examples of standardized variable. Now I'm going to post a link in the chat box I just did. You can click on that and it's going to take you to this page. Okay. And list 3 standardized variable. So you key in your answer here. All right. And when a lot of people have participated, we will talk about it. Okay. So what was the question again you asked? The question is, Josh is trying to see if wearing different shoes is going to affect his endurance, how far he can run. Okay. What things should he standardize in his experiment so that if he does run further or not as far wearing different shoes, he know it was because of the shoes, not because of anything else. Okay. So please try that. If you don't understand the question, that's okay. Just ask me. I'll try to phrase it in another way. Okay, there is a link in the chat that you have to click on to.
Please phrase it in another way. I don't understand it.
Okay, so one example is this, right? Yeah. So what he's gonna do is this. He wears the first pair of shoes, and then he runs. Let's say he runs 6 kilometers. Okay, and then on another day he wear the second pair of shoes, shoe B, and then he run. You only run 5 kilometers, right? So is shoe A better than shoe B, right? So he cannot definitively say shoe A is better than shoe B unless everything else was kept the same, right? Okay. So maybe he was tired on the second day. So he wants to make sure that he only runs on days where he was well rested. That would be an example of a standardized variable. Do you understand that? So what else does he have to keep the same during the 3 runs, the 3 trials, right? In order for this experiment to work? That's the question. Are you guys not able to access the link? I only see 3 people and the page. Okay, 4 people now. Or maybe you guys are just thinking about the answers. Okay, let me give you a couple more minutes to try out.
I'm not able to access the link. So is it okay if I put the answers in the chat?
Yeah, sure. Like when you click on the link, nothing works. Is that what you mean?
I don't even have the link. It's maybe because I'm using my phone. That's why.
Oh, okay. Yeah, sure. That's fine. All right. Just a couple more minutes. I'm just trying to keep you guys engaged, right? So it's not just me talking for like 2 hours, right? I could be a little bit dry. All right, so just key in something. Okay, that's very good. I mean, I have some results here. Let's take a look at what people has written. Okay, so here we go. How do I make this full screen? Oh, there it is. Okay, so people said the distance he run. Actually, that would not be a standardized variable. The distance he run is the dependent variable, right? That's what he's trying to observe. That's what he's trying to determine, right? How far can he run? So that wouldn't be something that you standardize. That would be something that you are measuring. That's the dependent variable. Okay, so I can see here run at the same time, where I see another one, like location, weather, temperature. All these are good ones, right? You don't want to be doing it on a rainy day versus like a sunny day, right? Because that could affect your endurance, right? So making sure that the weather pattern is the same every day, right? The energy level, very good. Sorry, yeah,
Right,
Kushina?
but I thought you said we're trying to find out which shoe works better.
That's right. So except for the shoe, everything else needs to be the same, right?
Yeah, so that's why we like, I guess a few of us put that the distance have to be the same, because I was thinking that, okay, if you ran 5 kilometers in one shoe,
Mhm.
and like it feels good, and then the next day he changed the shoe
Mhm.
and he ran 7 kilometers, it might feel like that shoe is not a good shoe because he actually ran in it a longer time. So that's why I was thinking that the distance would actually affect that. So I think I thought that the distance should be standardized also, so that
Okay, so if you choose to standardize the distance, let's say it's 5 kilometers for shoe 1, shoe 2, and shoe 3,
yeah,
and then the dependent variable would have to be something else. It would be let's say, how long does it take for you to complete that 5 kilometer, right?
okay.
Yeah, but that would be answering a different question, right? That would be answering if the shoe makes you run faster or not, right? That wouldn't be determining whether it increases your endurance, right? Okay, so like, because he's trying to see, how far he can run in different
The
shoes.
question was about endurance.
That's right, exactly. Okay, so I hope that helps. Let's see, run at the same time, of the day, I assume, right? Same time every day, people talking about the same thing. Proper nutrient he had, right? So you might want to have a similar diet, right? Just making sure that maybe you eat the same thing every day, just to make sure that it's not the food that, maybe don't drink coffee on one day, right, before you run, right? That would be something that could potentially mess with the result. And there was one that was good that I saw. Yeah, the speed that you run at, right? Okay, like you don't want to be going full sprint on one day with shoe A, and then just do the light jog with shoe B, right? Because that's definitely going to affect how far you can go.
I don't
Okay.
think I'm following. So
I'm sorry?
distance and time is not an answer for standardized variable?
No, it's not, because
Oh, wow.
you
So
cannot.
I'm lost.
No, that's okay. That's okay. I mean, like he is trying to determine how far he can run, right? He's trying to determine how far he can run with each of the shoes, right? So if that's something that you're measuring, that shouldn't be something that you're standardizing, right? Do you understand? If I'm trying to determine that example won't work. But you understand what I mean? Like he's trying to see how far he can run in each shoes, right? 5 kilometers, 7 kilometers versus 8 kilometers, right? You're not supposed to cap that. You're not supposed to fix that, because that's what you're trying to measure out. We will have.
It's not about comfort in the shoes, it's about how far he can run.
That's right, because the question was about endurance, right? Like how.
Oh, okay. So
Okay.
that makes sense. Okay.
All right, we will try another example in a little bit. But now, let's take a quick break. 5 minutes. We will resume at 9:38. Okay, so just go relax a little bit, and we will continue. Okay, so see you in a bit. All right, hello, it's me again. Let's keep going. So let's shift gear and talk a little bit about where this scientific method approach originates from. Like, who came up with this observation, hypothesis, experiment, these steps, right? Who came up with that? Okay. So it has to do with something called spontaneous generation. In spontaneous generation, it is a concept that originates in the mid to late 19th centuries. Okay, and it's the idea that talks about the origin of life. Right. So the concept of spontaneous generation states that life arose from non-living matter. Okay, so people came up with this idea because of observations that they made. For example, if you leave a piece of meat outside, eventually it's going to be crawling with maggots and flies. So people are like, oh, look, the meat, which is non-living, have given life to these maggots and flies. Okay, living things from non-living matter. And also, what people were seeing every now and then is that there are these fish and sometimes frogs, they rain down from the sky. And then that supported the theory of spontaneous generations, right? They were like, oh, all these fishes is raining down from the sky. The sky is non-living, right? And then the fish is coming down, which is alive, right? And that actually is a phenomenon that still happens every now and then, like nowadays. If you do a quick Google search, you can see Texas witnessed a rare weather phenomena as fish rain from the sky. And here is fish fall from sky with rain in northern Mexico, and then similar things in other parts of the world. Does anybody know why this happens? Where did the fish come from? Why are they raining from the sky?
I'm guessing maybe because it was, I guess, when water evaporated. I don't know.
Okay, yeah, that's a good hypothesis, Samina. Very good. Anyone else? Have you guys heard of this before? Fish raining from the sky, or is this first time?
Maybe because heard of it before.
Yeah. Why? What do you know?
Maybe,
what the reason is?
I've also
maybe volcano in the sea.
Sorry, Talam, one more time, please.
Maybe about the volcano in the sea, something.
Okay, yeah, I think you're getting close. Zoom user, you wanted to say something? I don't know what your name is. Sorry, I'm just have to read it. Or Alex, go ahead.
The tornadoes that bring the fish over.
Yeah, exactly, right. So like there is these tornadoes that swept through, like they're actually called water spouts, right? That they've swept through like maybe the ocean or the river, and then they scoop up all these fish and sometimes like frogs and stuff like that, and then they send them flying inland, right? Because of the strength of the tornado and water spout. And people thought, they were raining from the sky, but really it's just they got scooped up from the nearby bodies of water, and then they got sent down, right? Okay, but back then people didn't know, and so they used this as a evidence for spontaneous generation. So there is this a guy in the 1600s. His name was Francesco Redi. He wanted to test the hypothesis of spontaneous generation. He didn't believe in spontaneous generation, right? He thought it was nonsense, and that living things cannot arise from non-living matter, right? So he use the process of making observations, asking questions, right, formulating hypotheses, and so on and so forth, right? He essentially created the scientific method that we were talking about in today's class to test the theory of spontaneous generation. Okay, so he observed that flies and maggots can be seen around pieces of meat that were left out on the counter. Right, so the question, the logical question to ask is, where do flies come from? Is the rotting meat transformed into flies? Okay, so that's basically the observation and the question. And the hypothesis that he made was only flies can make flies. Rotting meat cannot be transformed into flies. Okay, so let's take a look at what he did to test the hypothesis. Okay, so if you have your actually, you know what, we'll just write it down on a note over here. Okay, so he basically had 3 setups. Okay, so there was 3 jars. Okay, you should draw this out as well if you can. So 3 jars. Oh boy, 3 jars. And he's gonna put a piece of meat in all of them. Right? Meat, and meat. Okay. So the first jar is opened. Okay, there is no cover in the first jar. No cover. Second one, he's gonna have a netting. Okay, jar with net on the top. And then last one, he's gonna have a sealed jar. Okay. This one's gonna be closed. Right? So what's the independent variable in this experiment? Independent variable.
Covering or leaving it open or just putting a net on?
That's right. So like type of covering, right?
Yeah.
Type of covering. Is it no cover? Is it with net, or with seal jar? And what was it that he was trying to observe? In other words, what is the dependent variable?
Spontaneous generation.
Okay. Anyone else? Manvira or?
Where the flies come from, maybe?
Okay, that would be the question. But what is it that he's trying to observe?
He's trying to put the
To see
fly.
whether the meat is gonna rot.
Oh, you know what?
Which
You,
If the rotten meat can make
Which
flies.
container is going to rot first?
which container is gonna do what, Manvira?
Rot first.
No, if the
Okay.
if the rotten meat can make flies.
All right. I think you guys are getting the right idea. Presence of flies, right? And maggots. I think you guys are very good at participating. So I think maybe we have to use the raise hand button so we don't all talk at the same time. It's good though. I love the the enthusiasm. But maybe use the raise hand for now so we can not talk over each other. So that is the presence of flies and maggots. Right? Basically, like, are there going to be flies or not? Okay, so that's the experimental setup. Now, what do you think happened? Common sense, right? Like, what do you think happens? Well, the one with no covers, right? You're gonna have the flies buzzing all over, right? And then you're gonna have the maggots, right? That makes sense? Okay. The jar with the netting, you would see the maggots and the flies buzzing on the cover. And over here, there will be like no flies, no maggots, right? Okay, so that's basically the result. Right? So based on this, he was able to conclude that only flies are able to make flies, right? The meat does not transform into the flies. Because if it did, you would see maggots and flies in a sealed jar as well, right? Do you understand that? Okay. Now, you look at this and you probably think, really? You had to do an experiment to figure that out? I mean, it seems kind of common sense, right? But remember, this was the 1600s, right? So like, you know, a lot of the knowledge that we have now was not discovered yet back then, right? I'm sure in like, 20, 30 years when we look back, you would be like, really? You didn't know that? You had to, do an experiment to figure it out, right? So things that we did in the past, right, obviously will become common knowledge in the future. So that is his experiment. Now I want you to think about standardized variable here. Okay, standardized. Just list them in the chat when you think of them. Standardized variables. What must he kept the same for all three groups in his experiment for this to be valid? Okay, Tash said type of meat. That's right. You don't want to be using some meats that are older than the other, same kind of meats. Yeah. Okay, the same environment. Yeah. You don't want to be leaving this, under the table and the cupboard, and then these are outside, right? You want them to leave them in the same place, right? Same location. Yep, same temperature, same weather, very good, right? And I'm just looking for one. Okay, that's it, Tosh, you got it. That was the last thing I was looking for, right? Duration, right? You want to leave them all out in the same place for the same time, right? All for like 7 days or something. Okay, so that was his experiment. Does anybody have any question? All right, let's go back to our, does the container matter? Yeah, you probably want to use the same jar, right? But probably is not as important as the other ones. But yeah, same jar, just different coverings though, right, Trish? Okay, where was I? I think I lost my file here. Okay, so that's just like textbook drawing. I like my drawing better. Next one. So even with this experiment, Raydi's experiment did not convince everybody. And some people are like, okay, fine. Maybe the meat does not transform into the flies and the maggots, but it still happens on a microscopic level. That's what people were saying. Yeah? It's gonna happen for like microbes, microorganisms, like the bacteria and stuff like that. They, spontaneous generation is still correct for that. So the question was finally answered definitively in the late 1800s by Louis Pasteur. You might not have heard of Pasteur, but if you drink milk or if you eat honey, drink honey, I don't know what's the right word, consume honey, I guess, you would have heard of pasteurization, right? Because the milk are pasteurized and the honey, I mean, you can buy raw honey as well, but those are not as safe, especially for kids. So like, pasteurized ones are more safe, right? That's based named after this person, right? Louis Pasteur. Right? Basically, to pasteurize something is to sterilize them, make sure there's no bacteria in them and stuff like that. So it's named after Louis Pasteur. In any case, he did a set of experiments to definitively show that spontaneous generation is not true. So in his experiment, he had a couple of flasks. Okay, so he has flask that has a swan neck, and then he has flasks that have a straight neck. So let me just draw this out for you. It's probably easier to understand. Okay. So he has a flask here, and then he has some broth in it. Broth, like chicken broth or something like that. Okay, some kind of nutritional broth. Okay, and then here he has another container, but it has a special swan neck flask. This one is just like a regular open tube flask. This one also has broth in it. Okay, so as part of the standardized variable, he boiled he boiled the broth for both of the containers. The purpose of boiling it is to kill off everything in the broth. If there were some microorganism in the broth to begin with, doesn't matter. The heat will kill them all. Okay. So after boiling them, the broth is sterile. There's absolutely nothing living in the broth, guaranteed. And then he just left the flask, on the counter, I suppose, for maybe a week or so. The time is not important, but he left it out there. And then he checked the contents of the broth afterwards, right? Only this flask has microorganism in it, okay? And this one continues to be sterile, right? So that allows him to conclude that spontaneous generation is not true, right? Even for microorganisms, they do not come from non-living things, because if they did, then this one would also have the microorganisms, right? But it doesn't. Right? So of course, now we know the bacteria came from the air, right? The dust particle carries those microorganisms and then they land inside. But because of the swan neck here, right? The particle, they were all trapped here. Like the bacteria don't know how to crawl up and then go into the broth, right? So that's why the broth is still sterile. Okay. I hope that makes sense. Let's see if you can answer this question for me. You can read it first, and then I will launch the poll. In Louis Pasteur's experiment related to the spontaneous generation hypothesis, what was the independent variable? Okay, I'm going to launch the poll now. Okay, just a couple more seconds. Make sure you choose something. Okay, so the correct answer would be the type of flask being used, right? He can control, right, to have the swan neck or just a regular bottle, right? It's not the type of broth. The broth actually would be a standardized variable. He has to use the same broth for the experiment to be valid. The presence of microorganisms, that would be the dependent variable. That was what he was observing in the end. We have quite a few people choose whether the flask was initially boiled or not. Both flasks were boiled, right? The purpose of boiling the flask is to kill off everything, right? That's actually part of standardizing the conditions, right? And the presence of flies, that was the other experiment with Brady. This is the Louis Pasteur that we were talking about, which is the broth experiment. Okay. We don't have time to go through this one, but basically, like, there is this internet thing that, there's a lot of fake stuff on the internet, right? And some of them are real, but we have to, use our critical minds to discern what's real and whatnot. And this is one of the things that was that I found, okay, on the internet. People are saying if you water your plants with microwaved water, right? This is day one. As opposed to like purified water, you're gonna kill the plant after a couple of days, after like a week or so. Okay, so watering the plants with microwave water will kill your plants. That's what the internet claims. Now, I just want to be clear. We are not talking about, you know, microwaving the water and then pouring it into the plant while it's like steaming hot. There is no question about that. You're gonna definitely kill your plants if you pour boiling water onto the plants, right? Whether it's microwaved or not. Okay, so that's not what they're talking about. They're saying if you microwave the water and then you let it cool down to room temperature and then you use that water to water your plants, you will kill your plants, right? So the people are trying to say that, see, microwaves are not safe, right? If the microwave water can kill the plants, think of what it can do to your body. What do you guys think, huh? Do you think this is true or not? What's your gut feeling? What's your hypothesis? If you think this is true, please choose A. If you think this is, nah, I don't think so, please choose B. Will watering your plants with microwave water kill your plants?
Is this photo like real?
Legit? Well,
Yeah.
I can tell you this is the photo I found on the internet. That's all I can tell you. The person claims that's what happens to his plants. Right? What do you guys think?
Sorry, what are the options again?
A, you believe, you think this is true. You think the microwave water will actually kill the plants. And then B, you know, you think it will not.
Okay, thank you.
Yeah. Okay, well, this is interesting. Yeah, so, you know, some of you think this is true, right? Some of you think this is not true. A lot of you think this is not true, right? Well, this is something that you can definitely set up an experiment to test yourself, right? And figure it out, right? Anyways, I am gonna let you, sleep on this one. I'll post a video for you to watch later. That someone actually did test this out, and then you will find out. Someone said, if that is true, we are using microwave for our food too. Yeah. I know, right? Interesting. Food for thought. Right? You guys should find out how microwave works as well, right? That would be something to consider. Anyway, moving on. We have 20 minutes, and quite a few more slides to go. Now we're going to move on to experiments involving human testing. Right? Now that is complicated when you involve humans, because we need to have higher standards when it comes to human subjects compared to if we just experimenting with plants, right? Or in some cases with animals, right? You need to have ethical guidelines that we must follow. And these ethical guidelines are actually, you need to have an ethical board to approve it whenever you do human trials. Whatever kind of experiment you're doing, when it involves human testing, you need to make sure that you get consent, and that the consent are actually voluntary consent. You cannot coerce someone into participating, right? You cannot like convince them, right? If they say no, then no means no. You cannot keep on, oh, but if you do this, blah blah blah, you try to convince them. That's not voluntary. Okay, so you make sure the person has voluntary consent, right? You want to protect them from physical and mental harm, right? Whatever drug you're testing, it has to show safety in the animal face, right? You cannot harm the person, right? Mental harm too, right? You can't just like, oh, let's do an experiment and see what happens if you lock a person up all by themselves for like a year and see what that does to them. Like that's not ethical, right? That's gonna probably cause a lot of mental harm, right? So you need to follow these ethical guidelines. Now, another thing when it comes to human testing, and we're just gonna focus on, say, testing a new drug, for example, right? We have to include a placebo. A placebo is essentially a sham treatment. Okay, it's not the real drug. It's just a substance that has no effect on whatever it is that you're trying to experiment on. Okay, and the purpose of the placebo is to minimize psychological effects and bias. Right. So like, my younger daughter, right? Like she got her tooth pulled out yesterday, okay, at the dentist. And then, she was whining about it afterwards, like, and I get it, right? Like it's traumatizing to pull a tooth out, right? She was like, oh, it hurts a lot. I'm not feeling comfortable. I can't sleep, right? So she's whining. And then we're like, oh, okay, why don't you have a bit of ice cream, and then, you know, the ice cream's gonna make you feel all better, right? She's like, okay, okay. Right, so she had the ice cream, and then she was all happy afterwards as well. Afterwards, she was all happy afterwards, right? Did the ice cream really, you know, fix the tooth problem? Probably not, right? Okay, but in her mind, right, it's like, oh, the ice cream is doing wonder, right? It's like, you know, it's cold, it's making me feel better, I'm all better now, right? So people have that kind of psychological kind of like self-fulfilling prophecy, if you know what I mean, right? Same thing with the melatonin that I was telling you about, right? People take it and they think it's going to help them sleep, and therefore they sleep better, right? Okay, so we don't want to have these psychological bias. We don't want to have these things affecting our results. That's why we need to have a placebo, right? The placebo is something that we know is not going to do anything for you, okay? But we give it to you without telling you it's a placebo. So let me give you some examples here. And when you test the new drugs, right? In treating migraine, for example. So like you would actually have a group where you are actually giving the new drug, and then you will have a control group where they receive no treatment, and then you will have a group where they're receiving an inert substance. Inert means it doesn't do anything, okay, no effect. Okay, and then you're going to compare the results of the three groups to see whether or not it has any effect. Okay. Now let me give you an example of a placebo outside of an experiment. Okay, like we actually have a placebo that are important in other contexts other than experiment. Okay, so this has nothing to do with research. This has nothing to do with testing a new drugs. Okay, so there is a birth control pill called Freya 28, and you know, the package looks like this, where you would take the birth control pill. And for those of you who don't know, okay, the birth control pills only works if you consistently take them, because you know it. You will learn this next semester, but then it. Basically, it mimics the hormone fluctuation in the body to prevent ovulation. Right? That's a long story short. Okay. So, anyways, you will take the pill every day for three weeks, and then you will not take the pill for 1 week. Okay. So they include these green pills, which are placebos. Okay. They don't do anything. They don't do anything. But the person will keep on taking it for that week. So I want to ask you, if they don't do anything, why do the drug company include the placebo in the package? What's the point of taking it if they don't do anything?
It's to get the user to, or women to get them to get get them to be consistent with taking their birth control on time every day.
Okay.
So the placebo helps with keeping them consistent.
Okay, great. Thank you, Alex. Anything you want to add, Dakisha? Sorry, Dinkira?
I thought it's because to see the effects of the real drug.
The effects of what?
The drug, like this one is placebo, right? It doesn't do anything. So they want to check the effect of the drug. When they take the placebo, there is no effect, right?
Okay.
So they just want to check the effect of the drug, I guess.
All right, thank you. But remember, right, these are drugs that has already passed all the testing and regulation, right? It's on the market, right? So, you know, we shouldn't be testing them on the users when they're on the market. But, you know, good try though. And I think Alex is correct. Sorry, Menvir, do you have anything you want to add before I go on?
Maybe the women, they are setting their mindset that
Okay.
they're taking medication.
Right. Okay. Thank you. So basically, these are for keeping track of times. Okay. They worry if the woman stop taking it for a week, they lose track of time. They're like, oh, wait, has it been 7 days already, or has it been 6 days? When was the last time I took the pill? Should I be taking the pill today, or like, should I not? Right. So like, it's hard to keep track, right? When you stop taking it all of a sudden, right? So that's why they included the placebo pills. Okay. They don't do anything, but then, you know, physically taking a pill today and you look at the package and you're like, oh yeah, I took it for 6 days. Okay, one more day of placebo, and then next day I will be back on the pill. Okay, so it's the placebo in this particular case is for the purpose of tracking time. Do you guys all understand? Okay, because of how the hormone works, and you will learn this again next semester, there is going to be a week where your body's own hormone will take over and you will not ovulate during that week. Okay, but for the other weeks, right, where your hormones are different, right, to prevent ovulation, you would need the pills to stop that from happening. Okay, so that sets the background story. But what happened was there was an incident where the company that makes this pill, they swapped the placebo with the actual pill. So people were getting 3 weeks of placebos and 1 week of the actual drug in the package. Okay, so when the people were taking it, thinking that it will be contraception, but actually it didn't do anything, right? So that's not a good thing if the person is trying to, you know, have birth planning, right? Like you think you are not ovulating, you think you're on the pill, you know, and then you might end up getting pregnant, right? So you know, there was this big recall of the pill, and women who were taking it were advised to use backup contraception, and you know, that was just you know, one example of placebo that were being used outside of doing an experiment. Okay, so when it comes to doing an experiment, we have two scenarios here. Okay? One is called blind experiment. In a blind experiment, the subjects, which are the people who are being experimented on, they don't know what kind of treatment they are receiving. Okay, so you're not going to tell them they're receiving the placebo, right? That totally defeats the purpose. The whole point is to tell them, okay, you're going to be receiving something, okay, and let them tell you how it feels afterwards, right? If you tell them it's placebo, then they will be like, oh, you're just giving me nothing. Like, of course, like that's not going to improve my symptoms, right? So you don't want the subjects to know, but the experimenter, they know. They know who's getting the placebo and who's not. The double-blind experiment is where the subject, the person who's receiving the treatment, does not know what is it that they're receiving, and the person who's administering it also don't know what they're giving. Okay, so some third party, they will have the data. They will know who's receiving what. And the purpose of a double-blind experiment is to minimize the bias not only on the subject, but also on the person who's doing the experiment. Okay, there are a lot of money on the line when it comes to developing new drugs. So we don't want the pharmaceutical company to, you know, skew the results, right, and be biased about it, right? Think about the COVID-19 vaccines, right? When they roll it out, they want to make sure that the results are done in a way that is proper. So, you know, the pharmaceutical company who's doing the experiment, they don't know who's receiving the placebo, right? Some third party that has no financial ties to the results, they will be the one who's analyzing the data. Okay, so that minimizes conflict of interest. So double-blind experiment is the gold standard of how experiments are being done. Okay, now I'm going to show you two graphs, and you know, this is a little bit confusing for some people. So let's try to focus and interpret this graph. So let's say there's a new drug called sleep, and it is going to be reducing the symptoms of jet lag. Right? Jet lag is, you know, when you fly to a different time zone, like your body gets all messed up and you can't sleep at night because day and night are switched, right? Yeah, so they're saying, okay, there's a new drug called sleep. It's going to help you reduce the symptoms of jet lag. Right? So this is the percent of people who are reporting symptoms of jet lag. Oops, there's a typo here. Jet lag. All right, so let's see. The control group. Control group are the people who are not receiving the drug. Okay, so no pills, not gonna give them anything. And 70% of the people say they experience jet lag, okay? Which is expected. You don't give them anything, they get jet lag. Placebo, right? Placebo, you give them something, you give them the pill, but you don't tell them it's the placebo. They don't know what is it. They just know, oh, there's a pill, I'm gonna take them. And you can see only 40% compared to 70%, right? 40% say they have jet lag. And then you give people the pill, the actual sleep pill, the experimental pill, and you also see, roughly 40% of the people experimenting jet lag. So based on this result, do you think the new pill works?
No, it doesn't.
No.
Why not?
Because there's still no effect. Even with the
But look, right? Only 40% of the people have symptoms as opposed to 70. That's like a 50% reduction, right?
Yes,
So do you think the pill works or not works?
it works.
It does work.
It works.
I'm messing with you guys, right? Let's do a poll. Okay. If you think that based on this result, if you think the pill works, please choose A. If you think it doesn't work, please choose B. Okay, thank you. So 68% of you said it works. 32% of you said it doesn't work. Okay. Here's the answer. The answer is that it does not work. Okay, and you're like, what? Okay, let's see why. If I look at the control, right, 70% of the people say they have jet lag. Okay, fine. If I look at the pills, only 40% of the people have jet lag, right? And we are testing it on 520 people. Right? If I just look at the control and the people who are taking the pill, it appears the pill is working because less people have jet lag, right? But we must also interpret the placebo result. You give people a placebo, and also only 40% of them reports jet lag symptoms, right? So what does it mean? It means it doesn't matter if you give them the actual pill or if you just give them, sugar pill. Both of them sleep better. Both of them doesn't have the jet lag. So that tells you it's just in the mind, right? You give them anything and tell them it will help you to sleep, and they end up sleeping better, right? It's like giving ice cream to my daughter, right, for the toothache, right? You understand? It's not the pill that's doing it. It's just the fact that you're telling these people, taking this will help you sleep. That's what's reducing the symptoms of jet lag. Do you understand? So if both placebo and the actual pill were able to improve the jet lag symptoms, then the pill doesn't work. I don't need the pill. I can just take the, sugar and it will work. All right. On the other hand, if the placebo group is similar to the control group and only the sleep drug, like the new drug, is able to reduce the jet lag symptoms, then we know it works. Because the placebo didn't do anything, and it shouldn't, right? Because the placebo is just like a fake pill, right? Okay, so only the actual pill was able to reduce the jet lag symptoms, right? Then we know this one works. All right. Any question before we move on? Okay, so you might want to think about that a couple times, on your own. Just make sure you have a good understanding of it. Okay, just one last question here. This is a very lengthy question. I will let you read it, and then I'll launch the poll. Because some of you say the poll is blocking the question, right? All right, let me launch the poll here. All right. I have people choosing basically every option here. It's good. That means we have to talk more about it. So let's see, 1 milliliter of experimental drug diluted in saline just means salt solution, is injected into 20 pregnant mice to determine possible side effects. Which of the following is a suitable control for this experiment? Okay. So if we are testing it on pregnant mice, then we shouldn't be using male, right? For our experiment. And we shouldn't be using non-pregnant mice either. Okay. So the control, should we inject them with 2 milliliters of drugs, or should we be injecting them with 1 milliliter of saline? So obviously, right, the experimental group is the group that's receiving the drug. The control group should not be having more drugs, right? They should have just the saline and nothing else. So the correct answer is E. Okay. We just have a couple more slides to go through. We will wrap it up next week. So next class is going to be next Monday, 8:30, and we will be doing lecture 2. I will post the link on eCentennial for you to download the notes. Yeah, so make sure you finish your study guide. I will post the solution to the study guide as well. And if you have any question, please feel free to email me. All right, so thank you for coming, and enjoy the rest of your week. Bye for now.
Thank you so much.
Bye, sir.
Bye-bye.